today for this lunchtime Tech Talk webinar. Today's Tech Talk is one of a series sponsored by the New Jersey Department of Transportation's Bureau of Research. That includes webinars, lunchtime talks, and other events. Tech Talks are meant to share and promote the implementation of research and innovative practices and the transfer of knowledge among NJDOT staff and others within New Jersey's transportation industry. Today, we're pleased to have Ray Murphy from the Federal Highway Administration join us to give a talk on the Everyday Counts Initiative, EDC 5, weather responsive management strategies. Ray will speak for about 50 minutes, and then we'll have about 15 to 20 minutes at the end for questions. Try to break by around 1:15 p.m. To submit a question, please use the bottom right chat box marked Q&A. Please submit all questions to the host. Questions will be addressed following the presentation. Professional development credits or AICP maintenance credits are available if you stay for the full session. Your name must be included among those who are registered today. Please also complete a feedback form that should pop up after the event. Now, with that bit of housekeeping out of the way, I'd like to introduce our speaker today. Ray Murphy is an ITS specialist with the Federal Highway Administration's Resource Center. Today, Ray will speak about EDC 5's Weather Responsive Management Strategies Initiative, which can increase the effectiveness of traffic operations and highway maintenance during adverse road weather conditions. This initiative promotes the adoption of traffic and maintenance management approaches that use road weather data by integrating mobile observations and connected vehicles, combined with informed decisions stemming from Pathfinder. In addition to expertise in road weather management, Mr. Murphy works in the areas of transportation, cybersecurity, and connected and automated vehicles. He has more than 30 years of experience as an electrical engineer, having served both in the U.S. Naval Civil Engineers Corps, or SEABEES, and the Illinois Department of Transportation. With that, we'll turn over the controls to Ray. Thank you.
Okay, thank you, David and Omid. Good afternoon, everyone, and welcome. Thank you for joining today's webinar on weather responsive management strategies. Again, my name is Ray Murphy. I'm with the FHWA, and I support the Road Weather Management Program. In today's session, I will provide an overview on weather responsive management strategies, or WRMS for short, how weather affects the transportation system, the different types of WRMS strategies, and the data used to support them. We will also talk about the relationship between Everyday Counts Weather Savvy Roads Initiative and the weather responsive management strategies, and the benefits of both maintenance and traffic operations. I'll then share some implementations with the weather responsive management strategies from a few states, the data that they use, the types of strategies they've deployed, and the benefits they have realized. And finally, we'll talk about deploying the weather responsive management strategy solution throughout the country. Again, as David had noted, if you have any questions or comments throughout today's presentation, feel free to use the Q&A chat pod. The Federal Highway Administration has championed innovations throughout its history by supporting innovative ideas to get highways planned, designed, built, and maintained. The Everyday Counts, or EDC program, provides an on-ramp to innovation by developing, launching, and administering strategic, innovative deployment throughout the country. EDC is a state-based model where we collaborate with stakeholders within the transportation community to identify and rapidly deploy proven but underutilized innovations, and it's every 2 years, to save money, save time and resources that can be used to deliver more projects for the transportation agency. WRMS focuses on the use of data to automate processes which can reduce the burden on field staff or TMC who previously may have manually monitored and entered events. It also, to shorten the project delivery process, EDC efforts have focused on innovative contracting methods that allow a project to be completed faster. Also, to enhance roadway safety, WRMS aims to get better information to agency maintenance managers. During winter weather events, this information can be used by agencies to make better treatment recommendations, plow route decisions, and staffing decisions to more effectively treat the roads and improve conditions for travelers. With more data points on the roadway from plow cams and mobile RWIS road weather information systems, travelers have a better idea of local road conditions. Similarly, during flood conditions, more data points can be used by agencies to understand what roadways will be impacted and when, in order to determine when and where to close roads or bridges, and the best approach for deploying equipment like water-filled barriers, or sandbag systems around the state to preserve critical infrastructure. Also, to reduce congestion by reducing crashes, enhancing traveler information, and promoting innovative technologies and contracting approaches. A number of EDC efforts help to reduce traffic congestion, as well as to improve environmental sustainability. For example, with enhanced road weather treatment recommendations through WRMS during winter weather events, agencies may more strategically place materials, reducing the overall environmental impact. And finally, to integrate automation through new technologies and connected vehicle applications. For more information, I have this website down there posted at the bottom if you want to pursue more information on that. Again, EDC is a state-based program where we foster a collaboration and deployment of new innovations every 2 years. Through the State Transportation Innovative Councils, or STIC network, and we'll talk more about the STIC later in today's presentation. We're on the 5th round, the 2019-2020, promoting these 10 innovations listed here. To date, we've had 4 rounds with over 40 innovations. And I got the website also, the EDC website, listed on the bottom of the page as well. From advanced geotechnical methods, collaborative hydraulics, project bundling, reducing rural roadway departures, safe transportation for every pedestrian, the STEP project, unmanned aerial systems, crowdsourcing for operations, value capture, virtual public involvement, and then the weather responsive strategies. Transportation agencies deploying integrated mobile observations, or the IMO solution, during the previous EDC4, they're building the foundations necessary to implement weather responsive management strategies during this EDC5 evolution. As transportation agencies implement the IMO, they are likely to continue to advance their strategies and practices. At the end of the EDC4 round, there were 24 states deploying IMO. However, there are several other agencies deploying related efforts, but outside of the EDC umbrella. Weather events lead to traffic delays, reduced operational effectiveness, and increases in crashes. The EDC4 Weather Savvy Roads innovation, it deployed two distinct road weather management solutions. The first focused on advancing vehicle-based technologies, also referred to as Integrated Mobile Observations, or IMO. And the second being Pathfinder, which brings together transportation agencies and the National Weather Service to provide consistent messaging on adverse weather and road conditions. These two solutions have the potential to be transformative by enabling state and local agencies to be proactive when it comes to weather, so they can manage the road system ahead of heavy rains, snow, or other storms. Under EDC4, the Integrating Mobile Observations innovation, referred to again as IMO, involves instrumenting transportation agency vehicles with road weather sensors and other automated data collection technologies to acquire location-specific data to support decision making. Under the previous round of Everyday Counts, EDC4, this effort focused on deploying the technologies to assess and collect weather and road condition data from transportation agency fleet vehicles. The focus was on supplemental data from ancillary sensors installed on the vehicles. These sensors can collect data about air pressure, air and surface temperature, spreader rate and materials, windshield wiper status and rate, and relative humidity. Dash cams are also included in the IMO. The IMO builds on vehicle-based technologies like automatic vehicle location, or AVL, and real-time communication that transportation agencies have already implemented. Collectively, this data provides maintenance managers a detailed view of the weather and road conditions, as well as asset locations along the highway network, and can be leveraged for a variety of uses. Transportation agencies benefit because it's a cost-efficient way to support maintenance, traffic, and performance management strategies. It affords a proactive management approach of roadway systems before the negative impacts of road weather occur, as well as real-time information about resource consumption that is more comprehensive and accurate, providing agencies with the data needed for decision making. And most of all, the IMO results in improved safety, mobility, and the economy, given the ability to more effectively maintain a high level of service on roads with better information for making treatment and staffing decisions during winter weather, in addition to providing better information to travelers before they make a trip or while en route via 511 or traveler information websites, including cloud cam images or video to see near real-time road conditions in areas that may not be covered by traditional fixed location road weather information stations. For more information, visit the EDC4 website listed here. The emphasis of data collection in EDC4 leads to a natural evolution for the next steps embodied in the EDC5 Weather Responsive Management Strategies Initiative for developing and implementing applications to use this data, specifically emphasizing road weather data from mobile and connected vehicle technologies to support traffic and maintenance management strategies during adverse weather events. Maintenance managers are constantly challenged to implement the most appropriate strategy during all types of weather events. Often with limited staff and limited budgets, the same thing goes for traffic managers. They are expected to provide safe and reliable travel options during weather events, especially when traffic volumes are at their peak. Across the nation, WRMS can be implemented to mitigate the impact of various dangerous weather conditions, such as in the northern states, where dangerous winter weather occurs. One could deploy WRMS strategies such as enhanced anti-icing and de-icing, plowing and snow removal, and in the southern states where dangerous weather can occur, including hurricanes, flooding, or fog, one can deploy the WRMS strategies as well, such as enhanced motorist alerts and advisories or variable speed limits. So, what's the motivation? What's in it for transportation agencies, and why should they care? Well, first and foremost is safety. Over the past decade, vehicle crashes have averaged approximately 6 million per year. 21% of those crashes, approximately just a little bit over 1 million, were weather related. The factors that contributed to those crashes include rain, ice, snow, and fog. On average, nearly 6,000 people are killed and over 445,000 are injured in weather-related crashes each year. Likewise, the delays associated with weather can be profound, resulting in significant losses in efficiency and productivity. About 25% of non-reoccurring delays are due to weather, and weather-related delays add about over $3 billion a year in freight costs. Additionally, there are environmental impacts from winter maintenance materials, the chemicals and aggregates, and their effect on watersheds, air quality, and the infrastructure. By maximizing the use of road weather data from mobile sources and connected vehicle CV technologies, weather responsive management strategies can improve existing traffic and maintenance management strategies by reducing weather-based environmental impacts on the transportation system within climate weather events. Weather responsive management strategies, they provide relevant and timely information to agencies to address the need for appropriate traffic intervention methods to mitigate the impacts of weather-related road and traffic conditions. They include traveler information, where mobile data is used as input for 511 or dynamic message signs to inform drivers of existing or impeding weather. Winter maintenance for snow and ice treatment, removal, staffing, materials tracking, and decision making, including the Maintenance Decision Support System, or MDSS, and as well for debris removal from high winds, flooding, and burn scar areas. Implementing weather responsive management strategy applications, they allow agencies to improve their management of materials, resources, and staffing, no matter what the challenges of the event brings. Winter weather events can cause a variety of impacts to road conditions, including reduced vehicle friction, reduced vehicle maneuverability, slower speeds, reduced roadway capacity, and increased crash risk. Standing water caused by flooding or low visibility conditions caused by dust storms, smoke from wildfires, fog or heavy rain, and snow conditions can also cause slower speeds and also increase speed variance, which in turn increases crash risk. Significant infrastructure damage can occur from wildfires and flood events. Debris flow, erosion, and flooding caused by wildfire burn scars can threaten roadway infrastructure and impact roadways with little warning. Winter weather events such as sleet, ice, frost, and heavy blowing or drifting snow reduce pavement friction and vehicle maneuverability, resulting in slower speeds, reduced roadway capacity, and increased crash risk. This is the focus for a lot of agencies implementing the weather responsive management strategies. Agencies may use a maintenance decision support system that leverages available road and weather condition information to make recommendations about the location, timing, and type of de-icing materials for maintenance staff to apply. Over 16 transportation agencies currently use automated processes like MDSS to support winter maintenance and operations, allowing these agencies to improve materials management and make better staffing decisions. Many agencies also use data from plow vehicles for WRMS applications on traveler information websites and mobile applications that sometimes include a weather layer with tracker plow or plow images. Flooding events such as tropical storms, hurricanes, heavy rains can result in significant flooding events, leading to reduced roadway capacity and major roadway infrastructure damage. One example of the WRMS implementation for flooding is in Delaware. They are actively working to better monitor and predict flooding. They use a robust RWIS network, RWIS Road Weather Information System network, and a fleet of vehicles equipped with mobile environmental station sensors and dash cams. They have 9 drones available to their CMC for flood response, depending on the severity of the event. Another extreme event is that of dust storms. They are difficult to forecast and quickly occur. An immediate lack of visibility, it creates dangerous conditions such as increased speed variance and, again, crash risk. One WRMS example application is in Arizona, where they're implementing a dust detection system that includes 11 sensors on a 10-mile corridor along I-10. The system automatically activates variable speed limit signing when and where needed. They will lower the speed limit in 10-mile-per-hour increments, and automatic ramp closures will occur when 35 miles per hour speeds are reached. Wildfires often leave burned land surfaces or burn scars. They are at a higher risk of debris flow, erosion, and flooding. As part of the WRMS in California, Caltrans uses a mobile RWIS in collaboration with the National Weather Service and local agencies to assemble forecast information and proactively close highways as needed when mudslides are predicted. They plan on expanding the burn scar management efforts to other predicted weather events such as winter weather and preparing for wildfires. So now let's look at the data sources that support WRMS implementation. The data can come from various resources, including agency fleet equipment, private vehicles, third parties, agency operators and road users, as well as agency infrastructure. In-vehicle sensor data provides direct and indirect measures of road weather conditions. Plow and material sensors may be collected via spreader controllers to determine spreader rate, material deployment, and quantity to assist agencies in managing treatment applications. This data can feed a MDSS, Maintenance Decision Support System, to enhance future treatment recommendations and performance management. Friction or grip sensors, they provide input on air pressure, air temperature, dew point temperature, relative humidity, and precipitation. Pavement condition sensors, they provide data such as surface temperature, pavement friction, snow, and water depth. Vehicle status data, this includes data such as brake status and windshield wiper rate, as well as controller area network, or commonly known as CAN bus data, that can provide vehicle performance information such as speed, acceleration, and engine diagnostics, and troubleshoot codes for identifying maintenance issues. Onboard video and camera data that can provide snapshots and continuous images of roadway conditions in real time. Automatic vehicle location, or AVL, with global positioning provides locational information such as lat-long, latitude and longitude, and elevation on a variety of fleet vehicles, including plow trucks, mower tractors, and light-duty supervisor vehicles. Other data sources include traditional data such as RWIS, Road Weather Management Systems, and the National Weather Service data, as well as new data sources such as road user reports, third-party data, and probe data as well. A recent focus on the program is using mobile observations and connected vehicle data to support traffic and maintenance management. The program developed and published the guidelines for deploying connected vehicle-enabled weather-responsive traffic management strategies, and I've provided that link on the bottom right there. So diverse agency needs, they dictate a variety of both internal and public-facing WRMS applications. Internal maintenance and traffic applications include automated processes such as decision support systems, resource management, which include end-of-shift reports, staffing decisions, materials use and management, and route optimization. Also included under internal applications is other agency information such as condition or performance reports. And for the public-facing applications, they can include roadside messaging via variable message signs or dynamic message signs, traveler information, again via 511 and transportation agency websites, variable speed limits, VSLs, and for road closures and lane restrictions. Okay, at the onset of EDC 5, agencies shared the following goals for implementing WRMS. Colorado is performing a statewide route optimization that can adapt to real-time weather events and historical data sets such as crash patterns, thermal mapping, and operational resources. Maryland is aggressively expanding mobile hours across the state. The agency piloted 2 mobile hours in the winter of 2018. They've added 52 mobile hours last winter, and they plan to significantly expand use over the next few years. Infrared sensors and cameras are part of the equipment. And there's also an iPhone in each vehicle that captures images while driving. And Bluetooth transfers information back to the server for live information, real-time information. Maryland plans on permanently mounting mobile hours to gather data 24/7, 365 for traffic incident and maintenance management. New Hampshire, they are augmenting existing technology in rural areas with AVL and mobile hours where there are currently no deployed hours to provide coverage. The ability to install more AVLs on trucks that patrol these remote locations, along with adding mobile weather sensors, is more cost-effective and allows the flexibility needed to move weather sensors and AVLs as needed. AVL and mobile hours data will be available to operators and shared with the public via traveler information mechanisms. Illinois is seeking to improve data integration for decision-making and performance management. Their goal is to have a central TMC that can be integrated at the district level so that the TMC can be used as a central hub to share information on statewide roads, internally out to the districts and then out to the public as well. Here in New Jersey, you are enhancing traveler information and maintenance management through vehicle data. Vehicle data is supplementing existing RWIS information. And here, in New Jersey, since weather can change from the river to the coast and north to south, having vehicle sensors driving along the state routes, they're expected to enhance both traffic and maintenance operations. Oklahoma is integrating plow data and RWIS data for forecasting predictions for more responsive treatment strategies. Data from plow vehicles will be integrated with the National Weather Service forecast information and weather data from RWIS. DOT staff will get alerts about when bridges freeze, allowing the Oklahoma DOT staff to be more responsive regarding treatment applications. One focus in Montana is data sharing technology in rural locations, since many parts of the state lack cellular service. The goal is to identify the best technology that can be used to convey information from the plow drivers to the web and back. This table, it shows some of the states and local transportation agencies that are currently using mobile or connected vehicle data for weather responsive management and the associated types of strategies they have implemented. Michigan DOT, their traveler information system through DMS websites and mobile applications, they estimate an average annual savings of about almost $700,000 due to staff time saved by by automatic system reporting. Minnesota DOT, they've implemented a web maintenance decision support, a web MDSS. It is a web-based form of the client-side maintenance decision support system used by transportation agencies to better manage roadways and resources during poor weather. It provides detailed hour-by-hour weather and pavement forecasts at the maintenance route level for greater mobility, safety, and decision-making needs. They use this data for road weather conditions, end-of-shift reports, material management, traveler information, and maintenance decision support. Nevada DOT, for winter maintenance treatment recommendations, they use it for material usage tracking and their traveler information system. South Dakota DOT has implemented a traveler information system which provides both condition and threat forecasts. Utah DOT uses data from their mobile app, which supports traveler information. Wyoming DOT provides traveler information via their dynamic message signs and are implementing variable speed limits. And by implementing the WRMS strategies, West Des Moines, Iowa, supports their traveler information website, materials management, and snowplow location and route optimization. As part of their weather responsive management strategies, several agencies have modified their traveler information systems in an effort to provide better flood-related data to travelers. Here, this graphic depicts the Iowa DOT. They redesigned their traditional closure icons on their 511 traveler information map to improve public understanding of the impact of major flooding events. The addition of a painted line showing the extent of closures has been effective and is now used for construction and other events. Flood thresholds were developed for notifying the traveling public. The notifications for rainfall rates and stream levels are based on information from local flood sensors around the region. Once the threshold is exceeded, an alert triggers that pushes display information on the traveler map. The alerts encourage travelers to exercise caution and avoid travel in identified areas where flooding is likely. As you can see in the left graphic of this example of what road closure alerts look like before system updates, and then the image on the right shows an example of road closure alerts with updates, which shows the extent of the closure through a painted line. So implementing weather responsive management strategies has led to the overall benefits: increased safety for travelers and maintenance staff, for more timely, accurate, and location-specific traveler information, alerts, and warnings; improved transportation system performance; reduced delays; increased good movements, etc.; enhanced traffic management operations, as well as increased efficiency of road treatment and maintenance management strategies, cost savings there as well; reduce negative environmental impacts through the more efficient use of materials. The deployment of WRMS strategies and applications has resulted in this sampling of documented benefits to date, as we have discussed on the previous slide. Direct benefits to the traveling public include safer pre-trip and en route decision making during inclement weather, given the availability of more information from mobile sources; better roadway coverage and localized messaging, where agencies are able to more effectively and cost efficiently collect data on the entire roadway network instead of just areas near the permanent ROAS. Unified messaging based on a more robust data set will in turn increase the traveling public's confidence in the information. That's important. More information, more informative travel advisories and alerts due to increased information accuracy, given more data from mobile sources and knowledge of real-time conditions. Transportation agencies will as well benefit to better sharing of resources, given a better understanding of road weather conditions. Enhanced alerting to staff or of priority maintenance locations, given enhanced road weather information across the entire roadway network. More efficient condition reporting by field and TMC staff, given automated processes. Optimized resource usage, given more precise recommendations to optimize the quantity and timing for material applications. And then finally, automated agency processes like road condition reporting or end of shift reporting reduces staff burden both for operators and maintenance field staff. As with many proactive investments, agencies implementing WRMS have encountered and have overcome a variety of technical challenges and institutional concerns. Remote areas such as in Arizona can sometimes be challenged with limited communication options. Arizona, as an example, is using a cellular switching capability for communications to connect to their network. Leadership buy-in has been addressed by having an agency champion that can demonstrate achievable benefits through performance metrics. Sometimes there can be a bit of hesitance gaining buy-in from field personnel. Through training and education, it's vital in sharing information with field staff on the scope of the technologies and applications. And funding can be challenging as well. Several agencies have applied for and have received aid and stick funding. Here are a couple of the WRMS deployment funding mechanisms. As I had mentioned earlier, the State Transportation Innovative Council STIC incentive program is a national network that brings together public and private transportation stakeholders to evaluate innovations and spearhead their deployment in each state. And the Accelerated Innovative Deployment, or AID demonstration program, provides funding as an incentive for eligible entities to accelerate the implementation and adoption of innovation in highway transportation. New Jersey DOT, they received an Accelerated Innovation Deployment, or AID grant, where they purchased and installed dashboard video cameras and mobile road weather sensors onto their maintenance trucks and safety service patrol vehicles. Data is being collected, includes streaming video, real-time pavement weather sensor information to support road weather management throughout the state. It will also help to advance the digital infrastructure, especially real-time reporting of traffic and weather conditions, as well as supplementing information to the traffic management center operators and field personnel for their situational awareness and operational decision making. In addition, these vehicles serve as mobile data sources that support connected vehicle applications. The goal is to use mobile road weather data to support maintenance and traffic operations response during inclement weather to improve safety, mobility, and maximize environmental impacts of weather on the transportation system. In closing, weather responsive management strategies that are being deployed under EDC 5 apply to all weather conditions, not just winter weather, but also flooding and summer weather events. There are two types of weather responsive management strategies, for traffic and maintenance. Under EDC 5, agencies can implement one or both of these strategies. The EDC 5 initiative focuses on weather responsive management strategies that utilize mobile or connected vehicle data. And finally, significant benefits can be achieved from implementing the weather responsive management strategies. Here are some of the resources and technical support activities that FHWA provides under the EDC 5 program. You can access a range of products and resources to help support agency implementation and adoption through the WRMS Toolkit website listed here. So thank you very much for your time and attention. If we can be of any assistance, please feel free to contact David Johnson. He is FHWA's Road Weather Management Program Manager, or myself. So at this time, any questions or comments, I'll hand it over back to you, David. Thank you.
All right. Thank you very much, Ray, for a very informative and comprehensive presentation. We have a few questions in the chat pod already that came in during your presentation, so we're going to go ahead and ask those now. But as a reminder to everyone else, before we get started, if you do have any questions, please go ahead and use the Q&A section now if you want to have your question answered as well. So the first question for you, Ray, is, have you faced any resistance from operators or third parties with providing things like automated vehicle location for their fleet? Have there been any privacy issues with providing this information?
No. As long as you don't, as long as most agencies don't work in a vacuum, that is open and transparent, and again, being inclusive, including field personnel, leadership. There hasn't been any substantial issues with privacy for AVL deployment or GPS. Not sure if that answered the question or addressed the concern.
I think it does. How do you think the data supplied by EDC-4 compares to the information other states like Virginia is getting from public entities such as WAVE during winter weather events?
How does that compare? I think both forms of information makes a more robust data set. So I would not say one over the other. I think the information from the IMO is more direct. You can better manage or oversee the data, maybe the accuracy, from the IMO implementation versus a third party. I think, in today's environment, you got to work with, you got to look at a robust data set, creating that type of data set from mobile or working with third parties.
Okay. We have two questions here. I'm going to link them into one. First part would be, what are the biggest challenges facing state agencies in implementing WRMS strategies? And the next part would be, do any states use metrics or reporting methods quantifying the benefits of using WRMS strategies? This would help making the case for implementing WRMS.
What was the first part again?
First part would be, what are the biggest challenges facing state and agencies?
Oh, the challenges, yeah. I think it's a combination of things. Like with most agencies, that's why we have these funding mechanisms that I just mentioned. Funding can be a big concern, but for the most part, it's really buy-in. Buy-in from leadership, as I touched on, and from the field. The full spectrum of being the folks involved in implementing such an innovation. You really have to have a champion for the agency that can show the benefits through performance metrics to leadership. And sometimes, as I noted, there's a hesitancy with field personnel. That there might be some concerns about the technology and privacy with iPhones with cameras and in the cab in the vehicle. But pretty much it is really reassuring through training and education. On both ends, buy-in from leadership and from the folks that's going to be out in the field at the maintenance yards or the garages, or it's full circle, including with the TMC. It's really that type of approach, inclusive approach. That's some of the biggest challenges.
Okay. And do you know
And
if any oh, go ahead.
And the second part, not off the top, here's my email address, David and myself. I can research that, and if you want to reach out to me, there's my email, and I can follow up on that with you. I don't know any states. I can touch base with David. I know he would for sure.
Sure. Another question is, what are some promising practices that FHWA is considering for EDC 6 relating to WRMS?
Again, I think David is looking, the program manager, he's looking into more applications that's geared toward flooding and hurricanes and you know, it's the full spectrum of what we're looking at for the next iteration. So everything's pretty much on the table. We haven't selected anything as of yet.
Do you know if these systems can be adapted, as was done for dust storms or wildfires, to capture rockfall data?
If these systems can be adapted, I'm not following.
The systems that were used for dust storms or wildfires in your presentation, could they be adapted to capture rockfall data?
Oh yeah. They have been. I'd mentioned a couple of agencies that they're looking at utilizing some of those applications specific to visibility, using it for flooding. You know, taking those applications and adjusting them to address different weather events. Yes, they can be adapted.
Great. And do you know of any states using metrics or performance measures that are quantifying the benefits of using WRMS, such as savings in time, improved safety, material, and/or labor savings?
There's a handful. I know Caltrans is doing such. I'm not sure if Sal Cohen or Wayne Patterson, if they're on the line, are they participating?
I cannot tell you that right now.
Oh, okay. Oh, I mean, do you see if Sal's on with us? Well, I know for sure Caltrans is. And again, I could get you a list of that. I wanted to, Sal and Wayne are with New Jersey DOT, and I wanted to see if we could connect them if they were participating.
I don't see Sal's name in here right now.
Okay. Next question or comment?
I think that was all the questions we have for right now. I don't see anything else in the chat box. But thank you very much again, Ray. It's a wonderful presentation. Just as a note to all the attendees, we're going to have this presentation hopefully posted on the NJDOT Tech Transfer website, hopefully in a couple of days, along with a copy of the presentation. So thank you very much, everyone, for attending.
Oh, thank you.